Okay, today we're going to be using the distributive property to help us solve multiplication problems. So picture an assembly room, like our gym or the cafeteria. So we're going to be talking about students filling rows in an assembly type of room. So the school assembly room has 5 rows of chairs with 20 chairs in each row. If the third grade classes fill 3 rows of chairs, how many third graders are at the assembly? Now I'm a little bit confused because I see 3 numbers here, 5, 20, and 3. Sometimes math problems may have information that we do not need. I would like you to read the question, how many third graders are at the assembly? Can you figure out which number in here do we not need to solve our problem? If you said 5, you are correct. There are 5 rows in the assembly, but we are only filling 3 rows. Third graders are only filling 3 rows. So I need to find how many third graders are at the assembly. Okay, we'll just keep that like that. What information are we going to use? Well, we know that there are 20 chairs in each row. So I'm picturing that, 20, 20, 20, 20, and they're filling 3 of them. This is kind of similar to when we gather together at the gym, isn't it, boys and girls? We have rows of third graders, and it typically is about 3. So the distributive property tells me that I can break apart the factor 20, and when I break this apart, it will help me to solve a simpler problem. Now, in my opinion, and probably yours as well, you probably can figure out already what 3 times 20 is, can't you? Because if you think when you're skip counting by 2s, you can just add that 0 and you could count on 20, 40, 60. So we have our answer. But the important thing here is that we're using a different strategy to help us. So here we have this problem, the problem set up over here. It's the diagram and it's going to show the rows. So if you take a look, here are the 3 rows, 1 row, 2 rows, 3 rows. And we simply are breaking apart 20 into 10 plus 10, because I know 10 and 10 equals 20. So I have 10 here, and then we fill in 10 there. So we're just solving a simpler problem here. So we're really solving 3 times 10, which is 30, and then we will double it to get 60, because this is the same problem here, 3 times 10. So it looks confusing when you look at it, but if you think about it, if the way it's set up here, it's easy for you to figure out when you see it visually. So then I have to add 30 and 30. 30 is the area for this section of third graders, and 30 is the area of that section. Okay, so we'll put those in there. 30 plus 30 is? Okay, so I know that 3 times 20 equals 60. There are 60 third graders at the assembly. Now, how we have to explain here, how does breaking apart the factor 20, how does it make it finding the product easier? So let's think, well, I know that I can use facts I know to find the product. And then an example of the fact that we knew is 3 times 10 equals 30. So that was the example of the fact that we knew to solve the problem. Okay, let's go on to our next problem that we have. Again, we're going to be thinking of rows of people. And so we have Megan. She is watching a marching band practice. The band marches by 4 rows of people playing instruments. She counts 30 people. Wow, it's a lot of people. 30 people in each row. How many people march in the band? So right now I'm picturing 4 rows of people, 30 in each row. Okay, so if I visualize that, it usually helps me. So let's fill in our information here. What do I need to find? Well, I need to find how many people are marching in the band. How many people march in the band? Okay, this up a little bit so we can see. All right. So what information do we need? Well, we know that we need 4 rows, and we're going to have with 4 rows with 30 people in each row. Okay, so that's the information that we're going to use. How are we going to use this information? Well, for me personally, I would be able to skip count by 30. So really it's skip counting by 3s and just having that 0 at the end. But for today, our lesson is using the distributive property. So we're going to try to solve it that way. So I'm going to draw a diagram. So I will draw a diagram. And I'm going to break apart 30. And I'm going to break it into 10 plus 10 plus 10, okay, to use the facts that I know. Because I know my 10s facts pretty well. So if I take a look at the diagram up here, we're going to try to make sense of this all. So I see we have grids here, and I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 10 here, and 10 and 10, which makes sense because there were 30 people in each row. So 10 plus 10 plus 10. And then I know there were 4 rows, 1, 2, 3, 4. So I'm going to write that in a text box here. I know I have 4 rows here. And then I need to put here 10 in this section. And then I have 10 in the next section and 10 in the next section. Okay, so now I have here 4 times 10. So if I would shade this here, you can kind of picture 4 rows here shaded. So 4 times 10 equals 40. It's an easier problem for me to solve. And again, then I would solve 4 times 10, which also equals, again, 40. And then 4 times 10 equals 40. Okay, and then I would add those all together, 40 plus 40 plus 40. See if you can figure out what that equals. Now here I have to record the steps that I use. So first, now I didn't shade mine because it's a little difficult for me to shade it on the program that I have. So I'm just going to write that I would shade 4 rows of 30, or 10 plus 10 plus 10. Next, so it's kind of like we're commentating, like we always shared, like a sports commentator and telling exactly what we did. Next, I find the products of each problem. And then I'm going to demonstrate that below. So 4 times 10 equals 40. Okay, so I have all 3 of those problems written out. Then I find the sum of the 3 products. And so I would add that all together. So 40 plus 40 plus 40. And did you get the answer for this one? 120. And then I'm just going to write this problem down below. This was the original problem that we solved before we broke apart. Okay, and then we have 120. And so I know that there were 120 people that marched in the band in the end of all of this. So how are we going to check if our answer is reasonable? These are always tricky to figure out. Well, first of all, I know that there are 4 rows of 30 people. So if I add 30 plus 30 plus 30 plus 30, it equals 120. So my answer is reasonable. Okay. That's just another way that I can demonstrate and show how I could solve the problem. I can double check my work that way. Okay. And then explain how you can use the distributive property to help you find a product. Well, just like we did today, I can break apart the greater factor to use facts I know. Then what we did, we can add. So then I never can type well when I know people are watching. I always type slower. I can add the products to find the total. So again, we just kind of broke down here the information, exactly what we did. We broke apart those factors to find out what the total was. Okay, so now we're going on to our last problem for today, onto the Sharon show. So now we're still talking about people filling seats. They're filling seats in the front section of the theater. The front section has 6 rows with 40 seats in each row. How many people are in the front section of the theater? So first, we're going to write the problem that we need to solve. So we need to figure out what is 6 times 40. Okay, so here I have my rows of 6, and I know I'm going to break apart 40 again, just as we did in all of our other problems. We're going to break apart 40, 10, 10, 10, 10. So 4 groups of 10 there, solving a simpler problem. And so we know that 6 times 10 equals 60. So now we're going to put that in for all of the others because, of course, we're just using the same problem here. We could always add 4 groups of 60 to help us, which we're going to be doing, but you could have did that to begin with if you just knew that and you didn't have to draw a picture to go with it. So now we know that 6 times 10 is 60, and now we're just going to solve for all of those. We just kind of repeat this here, which is the same problem. So last, I'm going to add all of those 60s up. Just as we did on the first 2 pages, we broke apart our 10s, multiplied, and then added their sums together. Okay, so go ahead and figure out what 60 plus 60 plus 60 plus 60 is. A strategy I could use, I think I know what 60 plus 60 is 120. I just kind of have that memorized. So then I can double 120. Go ahead and figure out what your answer would be. You said 240, you are correct. So there were 240. And I'm going to go up here and look how many people. Right after the words how many, that tells me what label I need to put. So how many people? 240. Good. So there are 240 people in the front section of the theater. Okay, so just to recap what we learned today. We learned that when we have a problem where we have a number here that is a multiple of 10, we could break this apart into 10, 10, 10, 10, and multiply using a simpler problem and then add them up at the end. This is just one strategy that you can use to solve this. If you're able to skip count by 4s, you could use that strategy to help you. So this is just one way you can, use the strategy that works best for you. Okay, and you'll fill out your Google form when you're finished with this lesson, and I will see you tomorrow for lesson 5.4.